Hello, this is Tim Lancia, and I am doing the regression section of the unique dataset assignment. So I went onto the UCI and found a dataset for miles per gallon. So I'm predicting the miles per gallon based off of cylinders, displacement, horsepower, weight, acceleration, model year, origin, and I'm ignoring car name because it's a string and there are a lot of unique car names, so I'm kind of just ignoring those because it would be a lot of work to try to actually properly use those names. Yes, and let's jump into the Jupyter Notebook. For the most part, it is the same. Pulling the data, randomizing the data. Here's just all those car names. Randomizing the data. I did not. And then here's kind of where I didn't include the car name, just because there's so many unique names, it wouldn't be that useful in this kind of scenario. So I just opted to ignore them instead of trying to figure out like a for loop to make them all figure out if it's a unique, give it a new number, put in an array. That sounds like a lot of work, so I'm just going to ignore it. And I am using it to find the miles per gallon. Let's see what is next. I used an 80-20% split like we did before, and normalized it. And the two models I'm using are linear support vector regression, so linear SVR, and then just regular SVR. I kind of wanted to see what the difference would be and if there was any major differences and that sort of thing, see if one was better than the other. Just thought it would be interesting. So when I'm implementing them, I don't really know the difference between the stuff in the parentheses. I'm not really exactly sure what the difference is there and why one has this and why one has the other. It probably has something to do with the linear kernels, but that was a lot of stuff that went over my head. So I'm just going to stick with it, and then here are the predictions, and then here are the kind of the summary, the results. So surprisingly, the linear support vector regression did actually a decent job. It only had a mean square error of 27, so like it was about 5 off average. Coefficient of determination was 0.25, which the closer to 1, the better. But surprisingly, SVR was not that good, and a mean square error of 106, and the coefficient of determination was almost -2. So, kind of interesting to see that just adding like a linear kernel could change the results so much. So I thought that was kind of interesting, and then I tried to plot it and realized that I need all the different labels and stuff, and that was a lot. So that's basically it. Apparently for this dataset, linear support vector regression is the better option over just regular SVR. It was kind of interesting to see all the differences. Yeah, so thanks for watching.